Welcome to solverfy.
So now we'll work on problem 62 from chapter 17. In this problem, we're asked to calculate the molar solubility of nickel hydroxide when buffered at pH 8, 10, and 12. So first, we can write down the KSP for nickel hydroxide, which we'll need for these problems. And it's equal to 6.0 times 10 to the minus 16. So in part A, we're asked about pH of 8. So if you have a pH of 8.0, we're going to have a pOH, which is 6.0, which means our hydroxide concentration is equal to 1 times 10 to the minus 6. So we can write over here our expression or our equation for the dissolution of nickel hydroxide into nickel 2 plus and 2 hydroxide ions. So we have no initial concentration of nickel, but we do have an initial concentration of hydroxide based on the pH of the solution, which is 1 times 10 to the minus 6. So we add x to both of these, and so an equilibrium is x for nickel and 2x plus 1 times 10 to the minus 6. So we set the KSP 6 times 10 to the minus 16 equal to x times 2x plus 1 times 10 to the minus 6 squared. Since KSP is very small, we eliminate the 2x, which gives us 1 times 10 to the minus 12 times x when we square 1 times 10 to the minus 6. And so if we solve for x, we get x is equal to 6.0 times 10 to the minus 4 molar, which is our solubility value for nickel hydroxide at pH of 8.0. So now we'll do the same thing for pH 10. So if we have a pH of 10, pOH will equal to 4.0, and OH, concentration of OH, will be 1 times 10 to the minus 4 molar. So we can plug this solution into the same expression we used for the equilibrium constant before. So we have x times 1 times 10 to the minus 4 plus 2x squared. We eliminate the 2x and we get 1 times 10 to the minus 8 times x. Our KSP value is, of course, still 6.0 times 10 to the minus 16. So we solve for x and we get 6.0 times 10 to the minus 8 molar. So finally, we can do it for pH of 12.0, which would give us a pOH of 2.0 and an OH concentration of 1 times 10 to the minus 2 molar. KSP is still equal to 6 times 10 to the minus 16, which is equal to x times 1 times 10 to the minus 2 this time, plus 2x squared. We eliminate 2x because of the KSP value being so small, and we get x 1 times 10 to the minus 4. And when we solve for x, we get a value of 6.0 times 10 to the minus 12 molar. So we can see from 8 to 10 to 12 how the solubility decreased upon the addition of the common ion, the hydroxide ion.